Hey everyone, welcome back to the System Design series where we are discussing each and every important concept in order to design a software system. In our previous session, we have discussed what are the important components we need to know to design a distributed system which can handle millions of users. In this session, we will discuss another important topic and a prerequisite before we start designing a software system. This is known as back of the envelope estimation. Back of the envelope means rough estimation. Let's understand why back of the envelope estimation is a prerequisite for any system design. Back of the envelope estimation influence the design decisions. We will see how based on the back of the envelope estimation we can decide how many servers are needed and how much memory and secondary memory we need for a software system. Here basically we estimate two important metrics. One is QPS, also known as query per second. We also use TPS interchangeably. The full form of TPS is transactions per second. So we calculate queries per second or transactions per second in order to understand the overall expected system load. Apart from this, we also estimate the storage requirement. Now let's understand the QPS or TPS and storage requirement in details. In order to calculate QPS, we need below information. If we know the daily active users of my system and the requests per users in a day, we can calculate QPS or TPS. In order to calculate QPS or TPS, we should know the power of tens. What is this? I will explain it in details. We will see how we can perform the calculations in order to evaluate QPS or TPS of any system if we know the daily active users and requests per users in a day. QPS and TPS influences mainly to understand the number of servers needed for our system. Apart from this, a lot more design decisions we take based on the value of queries per second or transactions per second. We will see all of these decisions in our subsequent sessions, where for each design we will evaluate QPS, TPS and the storage requirement, and we will see how we influence our design based on these values. Hence, these are very important and fundamental prerequisites to design any software system. Apart from QPS, we also evaluate storage requirement. In order to calculate the storage requirements, we should know the daily active users and requests per users in a day. Along with that, we should know the storage requirement per requests. If we know these two things, we will be able to evaluate storage requirement for our system to be designed. To calculate storage requirement, we need to know the power of tens again. We calculate the storage consumptions per day for the system. It influences the DB and blob storage size, the requirement of retention period, should I move the data to the cold storage for archival or not. All these decisions can be made based on the storage consumptions of our system. So overall, without knowing the queries per second and storage requirement of the system, you will not be able to design a system intelligently which can handle the millions of requests in future. Now, as we have understood that for both QPS calculation and storage calculation, we need to understand the power of tens. Let's see what it is and what to remember in order to evaluate QPS and storage requirement for any software system. These are the power of tens. 10 to the power 3 means K or 1000, and this also corresponds to KB. The accurate value of KB is 1024 bytes, but here we are assuming it as 1000 because it's a rough estimation. We are not evaluating accurate estimation here. We don't need to do that. If we do the rough estimation quickly to understand the load of the system, that will be enough for our system design. So 10 to the power 3 is nothing but 1000 and KB. 10 to the power 6 is in million, and MB, 10 to the power 9 is GB, 10 to the power 12 is TB, and 10 to the power 15 is petabyte or PB. Similarly, it is billion, trillion and quadrillion. This is nothing but the power of tens. You only have to understand and remember this. You will be able to calculate QPS and storage requirements very efficiently. Let's understand this with an example so that you will realize how we have to estimate QPS and storage for a system we would like to design. Let's take an hypothetical system to evaluate QPS and storage requirement. Let's assume we are trying to build a Twitter clone. We have 300 million active users, 50% users uses Twitter daily, 2 tweets or posts daily per user, 10% of tweets have media, and data retention is 5 years. These kind of information or requirements are critical to evaluate QPS and storage requirement. And QPS and storage requirement calculations are critical to design a system efficiently. Let's understand using this information how can we evaluate QPS and storage requirement. Let's calculate the daily active users. It will be 50% of 300 million, which is nothing but 150 million per day. And every day each user does 2 posts. So QPS will be 150 million into 2. So twice of 150 million tweets will be there per day. And we know one day means 86,400 seconds. But as we are performing rough estimation or back of the envelope estimation, instead of 86,400, we will use 10 to the power 5. What will be the value of queries per second here? It will be 150 million into 2 divided by 10 to the power 5. We will refer to this power of tens. Million means 10 to the power 6. So 15 into 2 into 10 to the power 7. So it will be 3000 QPS or 3000 queries per second, which is not less. One single server will not be able to handle 3000 queries per second. We will see in our subsequent sessions how to convert this QPS into the number of servers we need. But for now, I hope you have realized how we are converting this requirement into queries per second. Similarly, let's understand how can we estimate the storage requirement. Assume a normal tweet is of 200 bytes and tweet with media is of 2 MB average size. So what will be the total posts daily? 300 million, 50% of them are active every day and does 2 posts. So total 300 million posts will be published in the system. Let's calculate the size or storage requirement of these total posts. As we know, 10% of tweets have media. So it will be 300 million. Each tweet will have 200 bytes for sure, plus 10% of 300 million posts has media attached with it. So they will take 2 MBs extra. 300 million is nothing but 3 into 10 to the power 8. 1 million means 10 to the power 6. You can refer to this table. Into 2 into 10 to the power 2 plus 3 into 10 to the power 7, because this much is 10 to the power 8, but I need 10% of it. So 3 into 10 to the power 7 into 2 MB. Now MB is nothing but 10 to the power 6. It will come around 60 TB per day. Let's summarize whatever we have learned in this session. Back of the envelope estimation is a prerequisite for any system design. Before you start designing your system, you should know what is the expected load for this system, because that information influences your system design. Back of the envelope means a rough estimation. We calculate QPS, queries per second, TPS, transactions per second, and storage requirements in this back of the envelope estimation, where QPS influences the number of servers we need. On the other hand, storage requirements are indicator for our DB and blob storage size, retention period, archival mechanism, and many more. We realized for both QPS and storage requirement calculation, we need to know about power of tens. This table is sufficient to calculate QPS and storage requirements. Here if you see, we are not using exact values of KB because 1 KB means 1024 bytes. However, here we are calculating 10 to the power 3 bytes equal to 1 KB. This is just a rough estimate. The idea is to quickly calculate QPS and storage requirement, which will give us the ballpark figure and using which we can influence our system design. We took an example of a Twitter clone. We have seen how using this power of tens table we can easily calculate QPS and storage requirements without using calculator. In our subsequent sessions, when we will go through high level design of a number of systems, for each and every session we will perform this back of the envelope estimation, and at the end of this series I am sure that you will be very well versed with this back of the envelope estimation. Thanks a lot for watching this video. If you have learned anything new in this session, do not forget to like this video.